Hello students, in last class we have explained optimization, that is maximization and minimization for plus 3 first year students, and we tested first order derivative test, and we also continued for second order derivative test then, and this is the table for the condition table of maximum minimum. What this table shows, maximization is there when first order derivative equal to 0 but second order derivative is less than 0, and minimum is there first order derivative equal to 0, second order derivative greater than 0. I told you that it is minimum because after the point of minimum we find all the points are rising, and in inflection we find that first order and second order derivative both are equal to each other. With this table, we have also solved two problems, and we have to go for economic application of this maximization and minimization. As we know, economics always concern or search for optimization. So we have to go optimization, use of optimization in economics, use of optimization in economics. We can say it also economic application. Number one, market equilibrium. Number two, SC and MC relation, and number three, FP and MP relation. We will go to explain these one by one. Market equilibrium. As we know, every firm, whether perfect competition or monopoly or any other market, we find all firms are thinking of maximizing profit. So how maximum of profit is possible? What is the economic condition? We know beforehand that MC equal to MR, and MC must cut MR from below. In case of perfect competition market, we find that this is AR equal to MR, perfect competition market. MC is the curve here. MC equal to MR at this point and also at this point. But this point is optimization point because MC is rising to cut MR from below. In case of monopoly market, what we find is that in case of monopoly, we find that AR and MR both are falling, but MC cut MR. This is the point of equilibrium because MC is rising to cut MR from below. These two conditions we have read in microeconomics in semester 1, and the proof of this can be given mathematically while we studying optimization in case of single variable or single independent variable. So to proof of these two conditions, we go for mathematical proof. Now we know profit equal to TR minus TC. TR equal to P into Q. So it is function of Q. TC equal to SC into Q. It is also function of quantity. So when TR is function of quantity, TC is function of quantity, the profit is also function of quantity. Profit is also function of a quantity. Using optimization condition for maximum profit, what we find is that the first order necessary condition is d pi by dq equal to 0, because we know that y equal to function of x, the first order derivative dy by dx equal to 0. Similarly, here profit is a function of quantity, so first order function d pi by dq equal to 0, and second order sufficient condition, we will know that second order condition d square y by dx square for maximum is less than 0. Here also d square pi by dq square, it is also less than 0. Using these two conditions, we can prove these two equilibrium conditions of the market. Go for proof of this thing. We know profit equal to TR minus TC. Using first order necessary condition d pi by dq equal to dTR by dq minus dTC by dq. As we know that the change in total is called marginal. That is why change in total revenue due to small change in quantity, that is derivative, is MR. Again it is MC. So d pi by dq equal to MR minus MC. Taking the condition of d pi by dq equal to 0, first order derivative, what we knew that d pi by dq equal to 0. That is why putting this 0, MR minus MC. What we find here, that MC equal to M. The first condition of market equilibrium is proved here. Now, coming to the second condition or second order or second sufficient condition. Sufficient condition told that d square pi by dq square less than 0 for maximum, what we knew. So we find that d pi by dq equal to MC MR minus MC. This is this equation we find here in the first order proof. Now, taking the second order derivative of the first order, that means again getting derivative, we find that dMR by dq minus dMC by dq. What does it mean? It means d square pi by dq square equal to slope of MR or change in MR, we can write it slope of MR minus slope of MC, as derivative shows the slope of the function, and the second order condition is less than 0. If this is less than 0, this is also less than 0. What we find is that slope of MR minus slope of MC less than 0. That means slope of MR less than slope of MC. That means slope of MC is greater than slope of MR. What does this mean? Slope of MC is greater than, that means it is rising. So, in our figure, what we find? In perfect computation, AR equal to MR, MC is this, and we find this is the equilibrium because slope of MC is rising, that means it is increasing. In case of monopoly market, we also find the same thing. In a monopoly market, AR and MR, MC curve is like this. MC also caught MR from here, but here, and this is the condition because the slope of MC is rising. We proved that for profit maximization, any firm should try to have MC equal to MR and DMC by DQ greater than DMR by DQ. These are the two conditions. These are the two conditions we can use for our solution on market equilibrium. We can use or follow my book also, book Mathematical Economics 2, for all these explanations, and we will go to solve a problem from that book. The question is that the revenue maximizing monopolist profit is at least 1700. What is given? The profit of the monopolist should be at least minimum 1700, not less than that, maybe more. Its demand and cost functions. Demand function is given as P equal to 502 minus 3Q. And cost is given 400 plus 2Q plus 6Q square. 6Q square. Determine his output level and price and compare the value of the profit. And we expect that the monopolist should get a profit of 1700. Is this true or false? We will see. So first we use the first order derivative, MC equal to MR. This is the total cost. Marginal cost means derivative of total cost, and we find the derivative of total cost is here, 2 plus 12Q. Here MR. MR equal to derivative of total revenue, but we are given marginal price. So we have to find total revenue. Total revenue equal to P into Q. P into Q equal to 502Q minus 3Q square. So MR equal to derivative of this 502 minus 6Q. Now comparing MC equal to MR. This equal to this. So we find 2 plus MC equal to MR. This is the condition of equilibrium. MC we find is that 2 plus 12Q equal to 502 minus 6Q. So we find 12Q plus 6Q equal to 502 minus 2. So it is 18Q equal to 500. Q equal to 500 by 18. The answer is 27.77. This is the quantity produced by the monopolist here. So whenever MC equal to MR equilibrium is used, we always find the quantity. If we try to find price, the price equal to 502 minus 3 into 27.77. The answer is 418.69. If we want to find profit equal to TR minus TC. TR minus TC. What we find TR is 502Q minus 3Q square. TC is this 400 minus 2Q plus 6Q square. If we solve this by putting the value, we find the profit amount is 6545. 6545. What is given in the question? The monopolist at least gets 1700 of profit. But what we find out of calculation is that monopolist gets 6545 rupees of profit. So his profit is excess than that of the minimum he expected. So monopolist will be in the market and he will get a very supernormal profit. This is the problem on market equilibrium. There are so many problems in this book I solved. You may follow the book page number. This is the question of 68 page. In book 68 page, this question I have taken and solved it. Now we will go for another use of economics or another use of optimization in economics. That is SC and MC relation. We have another application also, APMP. After this we will solve that SC and MC relation. What we know from economic theory. Economic theory is that the SC curve is like this U shape, MC is like this, and we find three relations from there. First relation is so long as SC falls, MC less than AC. Again, so long as SC rises, MC greater than AC. And third relation is at the minimum of SC equal to MC. We can prove this by taking our optimization problem or optimization conditions. Now, SC falls. We will take this, but before that, we should know SC and MC. Let C equal to total cost, Q equal to output. So SC equal to C by Q, MC equal to DC by DQ. First condition, SC is falling. Condition relation 1, SC falls. What does mean? Any function falls means slope is negative. Any function is falling means slope is negative. Slope means we know derivative. So dy by dx less than 0. Here we find that cost is a function of a quantity. So SC false means dSC by dQ less than 0. As we know SC is C by Q, we can use here dC by Q, SC by dQ less than 0. C by Q is in quotient form. We use quotient formula here, that is Q minus Q into dC by dQ minus C into dQ by dQ by Q square means less than 0. What we find here now, Q into dC by dQ by Q square minus C by Q square less than 0. We can cut it here. And we find dC by dQ by Q less than, minus goes that side, C by Q square. Now the Q is taking off, cross multiplication. That means dC by dQ less than CQ by Q square. Now Q cancels out, so dC by dQ less than C by Q. This is the final result here. What does dC by dQ means? dC by dQ means MC, C by Q means SC. So we can write here MC less than C. And we took the condition, here is relation, that first correlation, so long as SC false, MC less than SC. We proved here by taking SC false and putting this derivative here. Again, the second condition is second relation. It is not condition, the relation. What is the relation? So long as SC rises, MC greater than SC. SC rises. That means dSC by dQ greater than 0. In the same fashion as we done in case 1, you can solve it by yourself. And we find that MC greater than SC. Nothing to be done. The similar process. Only the sign changes due to rise. Not more than that. Again, in case of third relation, minimum of SC. Minimum of SC. But we know minimum condition. The first order minimum condition is dy by dq equal to 0. Similarly, minimum of SC means dSC by dq equal to 0. And in the same fashion, nothing to be done more than that. Only sign greater less you will put this, or you will get equal, and you find SC equal to MC. This is the theoretical part of SC-MC relation. We will take one example of solution for SC and MC relation, the problem which may be asked in question in your exam. SC-MC relation. This proof is given, SC-MC relation proof is given in the page 71. You can follow it. Then coming to a problem. Problem is given in page number 74. question problem is given in 74. I took a problem B. Ek number B. C equal to 3x4 minus x square plus x. This is the problem given to us. And what we will be asked we will find SC, MC, minimum of SC, minimum of SC, and at the minimum of SC, MC equal to SC. We have to prove this. First of all, we have to find SC. How SC can be calculated? Total cost by quantity. The quantity given here is x. So SC equal to C by x. C by x means 3x4 minus x square plus x by x. That means x is factored out. 3x cube minus x plus 1 by x. So SC here 3x cube minus x plus 1. MC is a derivative of total cost. So total cost given here is a 3x4 minus x square plus x by dx. So derivative is 12x cube minus 2x plus 1. So we find SC, MC, and minimum of SC we have to find. How minimum of SC can be calculated? Minimum of SC equal to derivative of SC with respect to dx equal to 0. So SC we calculated this. So derivative of 3x cube minus x plus 1 by dx. What we find? 9 3 equals 27. With 3 9 x square minus 1. So equal to 0. 9x square minus 1 equal to 0 means 9x square equal to 1, x square equal to 1 by 9, x equal to 1 by 9 root equal to plus minus 1 by 3. But what we know is that quantity cannot be negative. So x equal to 1 by 3. Now the minimum of SC is gone. Again we put the value x equal to 1 by 3 in SC and MC. What we will find is that if both the answers will be same. That means SC equal to MC. SC what we calculated is that 3x cube minus x plus 1, putting x equal to 1 by 3. 3 into 1 by 3 cube minus 1 by 3 plus 1. Likewise MC is here 12x cube minus 2x plus 1. Now putting the value 12 into 1 by 3 cube minus 2 into 1 by 3 plus 1. What we find? The value of SC and MC both are equal, and that is 7 by 9. 7 by 9. So we find SC, MC, minimum of SC At the minimum of SC, we find that MC equal to SC. This is the problem will be asked in examination on SC and MC relation. Now we will go for the last use of optimization in economics. The last use of optimization in economics is FP-MP relation. FP-MP and relation. What is that relation? We know this is total product curve. This is marginal product curve. And this is average product curve. This is the log of variable proportion figure. And this figure gives the relation between SP and MP. What is that relation? There are three relations. So long as FP rises. Look at this. FP rises. What happens to MP? MP is higher than FP. MP is greater than FP. So long as FP falls. FP falls here, look at this. What happens? MP is going down. That means MP less than FP. Third one is at the maximum of FP. Maximum of FP equal to MP. At the maximum of FP and FP equal to MP. We have to prove these three things, just as we proved in case of SC and MC. Look at, first of all, we go to FP. We know Q equal to total output. L equal to labor used. We know that law of variable proportion is a short proportion function in which only labor changes. So we consider labor as a variable factor. So your FP will be total product by labor, that means Q by L, and MP will be derivative of Q with respect to L. Now we have to prove the first condition. FP rises. Rises means what happens? The function when rises, it gives a slope, positive slope. That means derivative will be greater than 0. So here function of labor. FP function and MP all are function of labor. So dFP by dL, FP rises, dFP by dL will be greater than 0. That means what the FP? FP is Q by L. So dQ by L by dL greater than 0. It is in quotient form. Putting the quotient rule, L into dQ by dL minus Q into dL by L square greater than 0. That means L into dQ by dL by L square minus Q into dL by dL cancelled out by L square greater than 0. Then we cancel out L and L square here. So we find dQ by dL by L greater than Q by L square, multiplying L here. So we find dQ by dL greater than QL by L square. L cancels out. So we find dq by dl dl greater than q by l. It is nothing, that is mp greater than fp. mp greater than fp. We proved the first one. This so long as fp rises, mp is greater than fp. Likewise, we will also prove this too by taking only the condition, the sign here. When we take fp false means this condition will be less than 0, this 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 will be less than 0, and this will be less than 0. The second condition, fp false, mp less than fp. So the maximum, if we take maximum of fp, what we find? fp by dfp by dl equal to 0, and this is equal to 0. Everyone will be equal to 0. Finally, it will be equal to 0. This is the proof of fp-mp relation theoretically. And we will also take some examples of mathematical examples here, but due to shortage of time, I leave this to you. If you follow this book, you will find the problems on the fp and mp relation as it's lucidly explained in this book. Thank you all. In next class we will see.